Hello, welcome back. Today we are going to look at some basic ideas from Chapter 3. Chapter 3 has some introduction to the demand theory that we are going to pursue throughout this course. I want to start Chapter 3 by just talking about the basis of Chapter 3, which is a discussion about the demand theory. From your previous set of courses, you have learned about the law of demand, how to derive a demand curve, and then from there how to derive a market model of demand and supply. But behind this downward sloping demand curve, there is a wide reach of economic theory which talks about utility maximization, or the process through which the consumer really makes a decision about purchasing a bundle of goods. Those of you who have taken intermediate microeconomics should probably have already seen this kind of utility maximization. A utility maximization is generally called a constraint optimization, where a consumer tries to maximize his so-called utility subject to a budget constraint, which essentially means the following. Given a certain constraint on the income, given the limited nature of the income of the consumer has to find the best possible combination of goods that he or she wants to buy that is going to maximize his or her utility. Utility is a concept that we regularly discuss in economics. Utility refers to the level of satisfaction that one derives by purchasing a bundle of goods. We can look at this utility maximization from either a graphical perspective or from a mathematical perspective. For Chapter 3, I would like to introduce both of them and then continue our discussion about demand theory in a graphical setup. So if we want to talk about utility maximization, which is our topic number 1, we are going to define some kind of graph that can represent the utility that a consumer derives from a bundle of goods. So we can think of this in a two-dimensional space. Let's imagine that there are two goods, X and Y, and we are going to define a straight line, which we usually call a budget constraint, which really gives an idea about what combination of goods the consumer can buy given the prices that he or she faces. So the slope of this budget line actually is the ratio of the prices of good X and good Y. Now what we do is that we superimpose some kind of utility representation on this budget constraint. So we usually talk about these functions which we call indifference curves that captures the level of utility a consumer can get by consuming different bundle of goods. So one can imagine a series of indifference curves, and we will say that at a point where one of the indifference curve is tangent to the budget line, let's say that happens with the indifference curve of 1, we will find a optimum consumption bundle for our consumer, which means that at that tangency point we are going to get a combination of goods X1 and Y1, and we like to believe that this particular consumption bundle maximizes the utility of the consumer subject to the budget constraint. So mathematically this same problem can be written as follows, and I'm sure some of you have seen that. So mathematically what we are trying to do is we are trying to maximize a utility function, which is a function of X and Y, the two goods the consumer is thinking about buying, and the consumer faces a constraint which in mathematical form is written like that. So we take the price of good 1, multiply that with the amount of good 1, which is in this case X, the consumer wants to purchase, plus we take the price of good 2, which is in this case Y, let's just call it Y1, doesn't really matter, has to be equal to or less than the income of the consumer, let's call that I. So this is what we call a budget constraint, and the total problem of maximizing utility subject to this budget constraint is called a constraint optimization problem. In this case, the constraint optimization problem is trying to maximize utility subject to the budget constraint that the consumer faces. before we move on, let us try to spend a little bit of time trying to understand what this budget constraint is telling us. The budget constraint is telling us that given the bundle of good X and Y the consumer is thinking about buying, the expenditure on good X, which is P1X1, plus the expenditure on good Y, which is P2Y2, here P1 is the price of good X and P2 is the price of good Y, has to be less than or equal to the amount of income that is available to the consumer. So this is a budget constraint because it shows that the consumption decision on X and Y are constrained by the income of the consumer. So that's our first concept. Let us now move on and try to understand what happens when there is a change in price of one of the goods and how it changes the consumption decisions of the consumer. Now, based on our understanding of the budget constraint, we know that whenever the price of one of the goods changes, it is going to change the slope of our budget constraint, which will make the budget constraint pivot around the original budget constraint. There are several ways the budget constraint will pivot depending on what kind of changes in prices are happening. In order to sort of show that, let us imagine a very general case where we are going to say that the price of good X is going to go down. Okay, so again, let's redraw the utility maximization problem that we saw in the last slide. But in this time, in order to sort of make this picture much clearer, we are going to ignore the indifference curves and just focus on the points on the budget constraint where the optimal consumption is occurring. So imagine that at the original budget constraint, point A is where the optimum consumption bundle was happening. Now imagine that there is a change in price of X. We know that whenever the price of X changes, in this case price of X is going down, X is becoming cheaper. As a result, the slope of the budget constraint is going to change, and we would like to believe that this will cause the budget constraint to pivot like the one that I just drew. So EF is our original budget constraint and EG is our new budget constraint. Now what we're going to do now is try to understand how a change in price of one of the goods, in this case X, is going to change the consumption bundle of our consumer. Now, we know that it might be easier to understand the effect of price change in a graphical setup, and probably what will happen is that if point A is where the original consumption bundle is, we might actually have another tangency with a higher indifference curve with the new budget constraint, and that's where the new optimal consumption bundle is going to happen. But in economics, we want to understand this process because we believe that this process actually is not a simple one. Because whenever the price of a certain product changes, it creates multiple effects on the consumer's decision. And our textbook is going to talk about two kinds of effect that happens whenever there is a change in price of X or Y or one of the goods. One is what we will call a substitution effect, which I am going to shortly write as SE. And the other one is what we are going to call as purchasing effect or purchasing power effect. So it's purchasing power effect. So if you read the textbook, you will learn that the purchasing power effect really captures the effect that price changes have on the real income of the consumer. Basically, whenever the price of X goes down, we can argue that the real income of the consumer will go up because since one of the goods have become cheaper, the consumer now has an opportunity to purchase more of both goods, and this is sort of like an increase in his purchasing power. The other one is what we call a substitution effect, where if the price of a certain product goes down, in this case the price of X, the consumer will find X to be cheaper, relatively cheaper than good Y, and that might also prompt him to buy more of the cheaper goods, because he obviously, we are making an underlying assumptions that good X and good Y are normal goods, and if that happens and the price of good X goes down, consumer would like to substitute the more expensive good Y for the more cheaper goods X. So they are going to buy more of good X as a substitution strategy. Now, these two ideas, the substitution effect and the purchasing power effect, can be analyzed in a graphical setup as follows. In reality, it is very difficult to separate these two ideas because they all happen at the same time. But in our theoretical world, in this two-dimensional space, we would like to carry out an experiment where we will be able to separate these two effects and understand their effect on the consumer's purchasing decision separately. The way we do that is that after we have identified how the budget constraint has pivoted, we start with our original consumption bundle point A, and along point A we draw a artificial or hypothetical budget constraint which is parallel to the new budget constraint but goes through point A. So the dotted budget constraint that I have just drawn is this hypothetical budget constraint. The idea behind the hypothetical budget constraint is as follows. Notice the hypothetical budget constraint is going through a point where point A is lying on the hypothetical budget constraint as well. So if we think about the hypothetical budget constraint and our original budget constraint, it appears that our consumer can afford this point A consumption bundle equally, which means that point A, the consumption bundle indicated by point A, is still affordable under the hypothetical budget constraint. By drawing this hypothetical budget constraint, what we have done is that we have literally taken away the additional purchasing power of the consumer, because we know that when price of a good changes, purchasing power expands, which makes things complicated. Now, if we focus our attention on the original budget constraint and this dotted budget constraint, we can analyze how the consumer is buying more or less of both of the goods as a result of pure substitution effect. Imagine for the time being that the consumer chooses a point such as B, which lies on the dotted hypothetical budget constraint. So if we compare between A and B, we notice two things. First of all, both A and B were equally affordable to our consumer, meaning that when he is thinking about going from A to B, his purchasing power did not change. What changed when we go from A to B is the consumer's desire to substitute some of the more expensive good Y for more cheaper good X. So if you compare between A and B, you would see that the consumer has purchased more of X and less of Y. The consumer has substituted more expensive good Y for less expensive good X. A movement from A to B is called substitution effect. Because by drawing this hypothetical budget constraint, we have been able to isolate the substitution effect from the purchasing power effect. So from A to B, we have substitution effect. Now let's think about how we can represent purchasing power effect on the consumer's purchasing decisions. Again, we can arbitrarily choose a point such as point C, which is on our new pivoted budget constraint. So now we are comparing a point like B, which is on the hypothetical dotted budget constraint, and point C, which is on our new budget constraint. The location of C could vary, and it obviously will depend on what kind of goods Y and X are. For the sake of simplicity, we can assume that these goods are normal goods. So if that happens, then the new and the final consumption point, which is point C, is going to be a place where a consumer is going to buy even more X and more Y. Okay, why is this happening? Because when we are comparing between the hypothetical dotted budget constraint and the final pivoted budget constraint, there is a similarity between these two budget constraints. The slope of these two budget constraints are the same, which means that the consumer is facing the same price, but since the pivoted budget constraint is a parallel upward shifted version of the hypothetical budget constraint, the consumer has more income on the pivoted final budget constraint than the hypothetical dotted budget constraint. So thereby, when we are comparing between B and C, we are seeing the effect of only the purchasing power, and the substitution effect is muted, because when the consumer is going from point B on the hypothetical budget constraint to point C on the new pivoted budget constraint, this is happening as a result of relative or permanent income of the consumer. So we can say that a movement from B to C is the purchasing power effect. Okay. So finally, if we want to summarize, we can say that a movement from A to B is substitution effect, a movement from B to C is the purchasing power effect, and finally, if we want to talk about something called price effect, which really captures the total effect of a change in price on the consumer decisions of the consumer, we are going to say that the price effect is happening from the price effect on this problem is that the consumer goes from point A to point C. Notice that a movement from A to C is sum of two movements, one from A to B, which is substitution effect, and the other one is from B to C, which is the income effect, or in this book, the purchasing power effect. I hope you do some you exercise on this particular graphical setup, because this sometimes requires a little bit of time to get used to this idea of how to decompose between the substitution effect and the purchasing power effect. Let us now move on and look at some other important topics that were covered in this chapter. We are now going to look at several measurements of this so-called elasticity concept. So from your introductory level economics courses, you have learned that elasticity is a very important concept in economics. Through various measures of elasticity, we really want to capture how changes in some of the determinants of demand changes the quantity demanded of the consumer. Traditionally, we look at three major calculations of elasticity. One is what we call the price elasticity of demand. The second one is the income elasticity of demand, and the third one is what we call the cross price elasticity of demand. Let's start with our most famous and most widely discussed concept of elasticity, which is called the price elasticity of demand. Okay, and price elasticity of demand is usually denoted as E small subscript d, which is actually a mathematical formula which mainly tries to capture the effect of price changes on the quantity demanded of the consumer. So we can from a generic perspective calculate elasticity of demand if we can figure out how much price changes have happened and how much quantity demanded has changed as a result of this price change. Now you also probably have learned that there are two ways to calculate this price elasticity. One is what we call the arc price elasticity, which mainly tries to give you an idea of how much quantity demanded has changed whenever there is compared to sort of like a average price change and compared to an average basic quantity level. So when we use the arc elasticity of price measurement, this particular elasticity formula looks like the following. So I will have quantity, changes in the quantity in my numerator. I will have changes in the price in my denominator, and I'm going to multiply another term with that, where I am going to have P1 P2 divided by 2 divided by Q1 plus Q2 divided by 2. Let us try to understand the second term. The numerator of the second term is sort of like an average price, and those average prices are going to be a weighted average of the original price and the new price. So P1 is the old price, P2 is the new price after the price change. Similarly, Q1 is the original quantity and Q2 is the change quantity after the price change, and this is how we are going to calculate the arc price elasticity. You can obviously simplify that by eliminating the 2's on both of the denominator of the numerator and the denominator, but and you can get a more compact arc elasticity measurement. The book talks about that in greater detail. Now, other than the arc price elasticity of demand, which is mainly what we are going to use in our economic applications, we can also talk about something called point elasticity. Now, the measurement of point elasticity is very similar to the arc price elasticity with some differences. In terms of point elasticity, the function is slightly different. In case of point elasticity, the elasticity is calculated as follows. We take the change in quantity and we calculate the change in price, and then the term that we multiply with this ratio is that we take the base price, which means the price that we start with, and we divide that by the base quantity, the quantity that we start with. Sometimes this point elasticity measurement is more convenient if we have like a functional form of the demand curve. Now, the book talks about some examples like that. For example, imagine that you have a demand function where quantity is equal to 500 minus 5p. So this is a traditional demand curve. You can see that there is a negative relationship between price and quantity demanded. Now, when we have a functional form for our demand, we really do not know what is P1 and P2, although we can use it. But sometimes when you have a demand function, we can utilize some of our concepts from calculus and can see that the change in quantity divided by change in price can actually be a differentiation of quantity with respect to price. If we see that, we can see that from this function, if you differentiate this demand function with respect to price, what you get is minus 5. Okay, so let's keep that in mind. Now, also let's imagine that your base price was $30, some arbitrary number. If base price is $30 and we have a demand function, we can calculate our base Q from that, which is going to be 500 minus 5 times 30. So it's going to be 500 minus 150, so it's gonna be 350. So we actually have now all the informations that we need to calculate point elasticity of demand. So our point elasticity of demand therefore can be written as delta Q divided by delta P times base P divided by base Q. So from the previous slide, we have found that my delta Q divided by delta P is minus 5. I'm going to now take the base price 30, divide that by the base quantity 350. And if you do the calculation, this will turn out to be minus 0.43. Now, this is an elasticity measurement which tells you that if there is a increase in price by 1%, then your quantity demanded goes down by 0.43%. That is exactly how we want to interpret elasticity calculations. Okay, so that's the price elasticity of demand. So there are two measures. The first one is the arc elasticity demand, where you take the average price and the average quantity. Those prices and the quantities are the average between the old price and the new price before and after the price change. The concept of price elasticity of demand has a profound effect on the firm's decision-making process. In order to capture that idea, let us now talk about the relationship between total revenue and elasticity. The reason why we are covering this demand concept or this demand theory in this class is because we want to really give you an idea about how much how the elasticity concepts affect the firm's total revenue. Now remember that a firm is trying to sell something in the marketplace, and whenever the firm is trying to do that, the firm really needs to keep track of how the changes in price is affecting the consumer's demand, because if the firm is thinking about cutting a price and hoping that as a result of law of demand, consumers would be buying more of their product and their total revenue might go up, this actually will depend on the kind of goods the firm is selling. If the demand for the good the firm is selling is less elastic, then we might actually have a different effect than if the demand was more elastic. So let's explain that idea. So we are trying to understand the relationship between total revenue and elasticity of demand. Now we know from our previous discussion that total revenue, let's delete this. Let's keep some space so that we can utilize our concepts. So what we are doing here, let me completely delete that. So total revenue is equal to P times Q, the amount of price the firm is charging and the quantity the firm can sell at that price. If you again utilize some notions from calculus, you can see that the change in total revenue is actually the sum of change in price and the sum of change in quantity demanded. This particular mathematical formulation can really help us to understand how changes in price and quantity really affects quantity demanded and the total revenue. Imagine, to illustrate that idea, let us imagine that for some reason price have gone down. Now if price goes down, you can see that changes in price is negative, it's going down, and as we have learned from law of demand, that if price goes down, quantity demanded is going to go up. So the question that we want to understand is, does total revenue on the left hand side go up as well? You should see clearly that if the change in price is less than change in quantity demanded, so change in price is less than quantity demanded, so the increase in quantity demanded is larger than decline in price, we can see that the total revenue is probably gonna go up. Let us go back one more time. So we are trying to understand the effect of change in price on the total revenue. So we are assuming prices are going down. If price goes down, quantity demanded goes up, and whether total changes in the total revenue, which is on the left hand side, is going to go up or go down will depend on the relative magnitude of the price change and the quantity changes. If in case number one, the changes in the quantity demanded is greater than changes in price, your total revenue goes up. But now we know that if this is true, the changes in the quantity demanded is larger than changes in price, we know this is the case when elasticity of demand is greater than 1, which means that your demand is elastic. Okay, so we can argue that when the demand, so based on our mathematical formulation, we can therefore conclude that if the elasticity of demand is greater than 1, meaning that the demand for the good is elastic, a decline in price will increase total revenue. Now, conversely, if the price goes up, and we are again trying to calculate the effect of this price change on my total revenue, and I am again looking at the relative magnitude of the changes in price and the changes in the quantity, and I know that my price is going up, my quantity demanded is gonna go down, and again if my change in price is less than my change in quantity demanded, my total revenue is going to go down. Let's look at this equation one more time. We are focusing on the relative magnitude between changes in price, which is that, and the changes in quantity, which is the second component. If the decline in quantity demanded is larger than increase in price, you should see that that is going to cause your total revenue to go down. So therefore, we can make some important conclusion. If the demand is elastic, an increase in price causes total revenue to go down, and a decline in price causes total revenue to go up. Something to be very important. Okay, so that was our first elasticity concept, the price elasticity of demand, the two different kinds, and how it affects the total revenue. The next elasticity concept that we regularly talk about is this idea of income elasticity of demand. What income elasticity of demand does is that we usually write it as EY. It measures how much quantity demanded changes when income of the consumer changes. So we usually write income elasticity of demand as percentage change in quantity demanded when there is a change in income. Okay. Most of the times we try to use the arc elasticity measurement, so we can rewrite this as delta Q divided by delta Y times Y1 plus Y2 divided by Q1 plus Q2. So this is like the arc elasticity measurement. We also know that if this EY is greater than 0, which means that whenever there is a increase in income, the quantity demanded increases. We call this kind of goods for which the income elasticity of demand to be positive to be normal goods. If on the other hand this elasticity of if this income elasticity is negative, which means that whenever income increases the quantity demanded actually goes down, we call those goods as inferior goods. Okay, so this is kind of exciting. So income elasticity of demand also has very important implications for us. Now the next elasticity concept that you all have learned is this idea of cross price elasticity. Now the cross price elasticity of demand is written as follows. We usually call it E cross, is going to measure by how much the changes in the quantity demanded of good A happens whenever there is a change in price of another good, let's say B. Obviously the relationship between good A and good B are important. We can say that if this E cross, let's just call it EC, is greater than 0, which means that whenever there is a 1% increase in price of good B, there is a 1% increase in quantity demanded for good A. This is very important. So why would the price of good A goes up and the quantity demanded for good, let me repeat that statement. So if this is positive, it means that if there is a increase in the price of good B, there will be an increase in the quantity demanded for good A. So under what situation can that happen? So we in economic theory we say that if this is true, if the cross price elasticity is positive, good A and good B are substitute goods. So let's think about a real life example. Imagine that Coke and Pepsi are substitutes. Coke is good A and Pepsi is good B, and suddenly there is an increase in the price of Pepsi. If the price of Pepsi goes up, consumers treat Coke and Pepsi to be substitute goods, and they would probably substitute away from Pepsi, and buy more of the other good, which is Coke. So an increase in the price of Pepsi, which is denominator, will lead to an increase in the demand for Coke. So they are substitute goods. If on the other hand, this is a negative number, we will call these goods to be a complementary goods. Examples of complementary goods are numerous in our economics. We can think about coffee and sugar as complementary goods. So if the price of coffee goes down, consumer likes to buy more of coffee, and if they like to buy more coffee, their quantity demanded for sugar as also increases. So in that sense, they are complements. Okay. Before we move on to a discussion about the combined demand elasticity concepts, the chapter introduces a very interesting concept called advertising elasticity. This is a relatively new idea, because in your previous set of courses you really haven't seen this, but you have to understand that this is nothing new. When we define a demand function, we say that quantity demanded is a function of various factors, and one of them is advertisement, which means that a firm would like to spend money on advertisement so that they can give incentive to the consumers to buy more of their product. We know that advertisement is a very important decision making process for the manager, for the firm as a whole. So our advertisement elasticity gives an idea about how changes in the expenditure on advertisement really affects the quantity demanded. So yeah, mathematically, this is obviously a mathematical concept. Your advertisement elasticity is calculated as follows. You calculate the percentage change in quantity with that, and you divide the percentage change in advertisement, and you get your so-called advertisement elasticity. You obviously can use the arc elasticity formula, where your denominator could be delta Q, the changes in quantity demanded. Your numerator could be changes in advertisement. With that, you can multiply a weighted average of the advertisement of 2 periods. So ADV1 could be the original advertisement expenditures, ADV2 could be the new advertisement expenditures, and you can keep track of how consumption has changed, the quantity demanded has changed from Q1 to Q2. So you can use the advertisement elasticity as well. Okay, so this is something new, and this is obviously exciting. If you are given a demand function, which you might be in the exam, you can rewrite the first term as sort of like a differentiation. So ADVQ, delta Q divided by ADVQ, and the second term can be just a weighted average of the two different advertisement level divided by the two different levels of quantity. So that's your advertisement elasticity. The final concept in this discussion in this class lecture is this idea of a combined demand elasticity, which will try to combine two important measurements of elasticity, the income and the price, and try to give you an idea about what happens to quantity demanded when both price and income changes at the same time. The formula is as follows. Economic theory argues that the percentage change in quantity is going to be a weighted average of the elasticity of demand times the changes in price plus in income elasticity of demand times changes in income. So our total change in quantity demanded is a weighted average of the price elasticity of demand and income elasticity of demand. So this is very important. Why is this important? Why do we want to combine these different measurement of elasticity? The answer is as follows. Imagine that you are trying to get an idea about how much quantity demanded is going to be in the next period. Provided that you are thinking about cutting your prices, and you forecast that there is going to be a changes in income from period 1 to period 2. Our economic theory says that we can really forecast or predict what is going to be the quantity demanded in the next period, which we call period 2, which will be equal to the quantity demanded in period 1 times 1 plus elasticity of demand times percentage change in price plus elasticity of demand for Y times percentage change in Y. Okay. So notice that what we are doing is that in order to predict the future quantity, we are utilizing this overall changes in quantity as a result of changes in price and changes in income at the same time. I hope so this concludes my class lecture. I hope the class lecture was useful to all of you. If you have any question, please send me an email or get in touch with me during my office hours, or just come to my online office hours. Thank you very much and have a nice day.